All right, welcome back again here. We're here to kind of look at the guts of the rule of 70. So, if you find this a little bit daunting, don't worry. It doesn't need to be. You can just pause, you can look at things, you can slow me down, you can speed me up. But the way that the rule works relies on this basic constant growth rule that I introduced in probably the first or second video here. And that just tells us what the variable of interest is, right here, yt, at any point in time, given a starting point and a growth rate and a period of time, right? So we can know yt as long as we are given the starting point, the growth rate, and where we are in time. Okay, so what does a doubling mean? Well, a doubling means that we start with this y0, and then we go to 2 times y0. So doesn't that mean that our yt, right, this yt becomes 2 times y0? And so what we're really interested in is when does that happen, right? What's the time period? When does yt reach 2 times y0? Why not? What we started with. So from y0 to 2y0, well, then that just means, right, start at y0, 2y0. We know what y0 is already. We know what g bar is already. And so again, all we're doing is trying to figure out, oh, what's t supposed to be? So the trick here is how do you solve this? If you're wondering where the y0s go, well, they exist on both sides of the equation, and we can just cancel them out. And that's how we end up with this 2 equals 1 plus g bar to the power t. And g bar is just that, like a 5% or a 10%, it's whatever the growth rate is. So what do we do for that? How do you solve something like this? Well, the way to solve something where your variable of interest is in the exponent is to take a logarithm of both sides. So I'm taking the natural log, right? That's this symbol ln. This is something you should have run into probably in high school math somewhere. If you look at a scientific calculator, you see the little thing that says ln, natural log. It's just a function, right? There's a value to natural log of 2. It's about 0.7. So we take the natural log of the left side. We take the natural log of the right side. We end up then with this expression. We want to solve for t, so we divide through both sides by the log of 1 plus g bar. And so we end up with this. It's actually 0.69 and a bunch of other numbers. So we round that off to 0.7. And so we know now this is basically the rule of 70. And then we call it the rule of 70 because the rule of 0.7, I guess, isn't a sexy or something, but that also allows us to just use whole percentage growth numbers. Again, not whole, but just allows us to use percentage numbers for growth instead of decimal numbers for growth. If you wanted to, you could call it the rule of 0.7, and then for g of 5%, you'd use 0.5 or 0.05 instead of just saying 70 and 5. Okay, but anyway, that's how the rule of 70 works. That's why it works. It's very useful, and it's a really good way to very quickly understand what kind of growth rate you're dealing with, what kind of time scale you're dealing with for constant growth. Okay, in the next video, we'll start working a little bit more with this. We're basically going to look at things from another angle and keep working with some growth stuff. So thanks for watching, and I will see you in the next video.